So today we're going to be talking about point mutations and their effect on amino acids and proteins. The pennies are representing the bases in DNA and the dimes are representing the bases in RNA. Purines will be shown by heads and pyrimidines will be shown by tails on the coins. If we have a point mutation from a purine to a pyrimidine, it's going to be a transversion, so we will flip the coin from heads to tails or tails to heads. And if we have a point mutation that changes the purine into a purine or a pyrimidine into a pyrimidine, it's going to be a transition, so we will not flip the coin. Our coding strand of DNA will be transcribed into our RNA, which will then be translated into our amino acids. So I'm using a bunch of guitar picks and different coins to represent amino acids here. So we're going to look at all these different mutations to see what sort of differences they cause in amino acids, starting with a missense mutation. So we're told that a point mutation occurs here at the circled base, and it turns that A into a T. And since this is going from a purine into a pyrimidine, we're going to flip our coin, which is originally a heads for A, into a tails for T. So this is a transversion. So this mutation is transcribed into our RNA, causing a change in one of our amino acids into a Phi, which causes a missense mutation because one of our amino acids is different from the wild type. So as you can see by our little objects, which are showing amino acids, one of them is different from the wild type. So now we're looking at a nonsense mutation. We have a point mutation with this G base right here, and it's mutated into an A. So we don't flip the coin because they're both purines, which means that it is a transition point mutation. And this causes this G down here in the RNA to be converted into an A, which codes for a stop codon instead of our original TRP amino acid. So now our nonsense mutation caused just one amino acid. So now we're going to be looking at a silent mutation, and we're going to be changing this T right here into a C instead. So since they're both pyrimidines, we are not going to flip the coin. It's still going to be tails. So this is still a transition, not a transversion. So after transcription, our codon is ACC, and before it was ACT, but both of those codons still code for our THR amino acid. So it's going to be the same as the wild type. So now we're going to have a read-through mutation, which changes this A base into a C. So it's going to be from a purine to a pyrimidine, meaning that we flip the coin, it's a transversion, and that changes the stop codon into UGC for cis. And instead of stopping there, we keep going and adding more amino acids to the protein. So this is what our read-through mutation would look like. And we don't stop there. After we have all these amino acids, it would just keep going until we finally hit a stop codon.